Okay, so again, as it relates to sailboats, the deeper the curve, the more the sail is going to be good at going downwind, directly downwind, and uh, the the higher the aspect ratio and the less severe the curvature is the sail will be tailored for going tight to the wind or pointing as high as possible. Okay, so knowing what we just discovered, if you wanted to generate power by harvesting the wind, which would it be? Would it look like this, or would it look like that? And the answer is this. So remember this. So which is actually getting more work done? The sailplane gets more work done. It captures more of the fluid. It falls slower, 2 to 3 knots as opposed to 17 knots. However, there is a place for this, and so let me show you here. So, well, something like that. Okay, so if you want to generate power, this is the number one way to do it. You have basically 3 wings that are spinning around, and it's basically a propeller. And this will generate more power than the parachute method, which is actually, there are some vertical wind turbines, and they do work. They are not quite as efficient, but they are this, they're kind of like, they're not quite a parachute, they're not a semicircle, but they are sort of designed in the way to capture the air. So the air flows this way, and it captures into this section, and it basically rotates around. And so this is the most efficient at generating power. This is less efficient, but there are advantages to this in that with this one you have to always point it towards the wind, and so you have to have a mechanism to steer it always towards the wind. With this one, this thing will spin no matter which way the wind is coming from, and so these work good in cities where there's a lot of shifts in the wind direction. And actually, something like this would be really good down the middle of a highway, where the cars, basically drag a bunch of air this way, and then the other cars drag air that way. And also, if you put these next to each other, these will work better because they kind of feed off of each other. They create almost wind for each other. These have to be spaced out further apart because you do not want any air to be disturbed when it hits these. Okay, the other difference is the speed. Okay, so this kind of windmill, the tips of the blades are traveling so fast that some of the larger ones are actually they travel at like the same speed as a jet airplane. So that's another characteristic of high lift is the speed at which it's slicing through the fluid. And these are much shorter, so they're not going to be spinning as fast. But so that's the major difference. So if you want to generate as much energy from the wind as possible, you use the concept of lift. And if you don't have a lot of space and the wind keeps changing directions quickly, you can still use this this vertical axis windmill. There's one more observation I would like to point out. about this style of wind turbine. If you look at the top view, let's see here. So let's say air is flowing this way. This curve will create lift in this direction, and this will create lift in that direction. So because these are at a distance from the center point in this orientation, this is acting more like, actually like this. So this is like an airfoil shape, a curved shape, and so is that. So this type works in one orientation, it works almost like a parachute, and in the other, it changes into generating motion from lift. So this one is not total drag. It's somewhere in the middle between total drag and total lift.